Okay, so let us start with the applications. Application of air refrigeration and cooling system. So you can think of supplying your equipment to hotels, supermarket and restaurants, even schools and universities. They require fairly used system to keep that spaces inside at comfort zone. You also require cooling systems, specialized and customized cooling system for hospitals and laboratories, especially designed to meet certain requirements where they can keep their specimen, they can conduct their experiment in that control zone. Apart from that, we have data center and telecoms where they need to keep their equipment at certain desired temperature. And just like hotels, think of offices and business centers. So these are the areas which we are going to play with and the equipment which we are going to design. Now we are going to concentrate on that. So in our next slide, we are going to talk about the kind of cycles which are used in making cooling system for the areas which was listed in the earlier slide. So the technology which I feel which is quite commonly used nowadays is vapor compression cycle. However, we cannot ignore adsorption cycle, but comparatively I feel like vapor compression cycle it has more applications and it is more convenient to make it and design rather than vapor adsorption cycle where there are use of some certain chemicals and it becomes a little difficult to handle. So throughout my experience, I would say that I have seen about 80 to 90% of the places asking for the system based on vapor compression cycles. My client, they all get demands and inquiries for this system rather than asking about anything on adsorption. So that's the reason I have made my tutorial in this way so that it could be well suited according to the market demand. Okay, so the next slide which we have here is the basic understanding. I'm not going to read all this. So I'm going to tell you about what is the main extract of this slide. Here you can see the basic refrigerating cycle which is comprised of four equipments, compressor, condenser, expansion device and evaporator. So compressor and condenser, you can think of CC, take off the first letter CC and you have 6 feet. Then we have expansion device which is with the name EE, so you can think of completing this cycle with CCEE. So for the next time whenever you are thinking about which equipment is connected in what sequence, then you can think of this small way of memorizing. So CC, compressor, condenser, EE, expansion device and evaporator. Okay, so here the compressor and expansion device, these are ready-made items you need to buy. You cannot do any changes on your own. You cannot make any changes. But what sizes you need to ask for or look around in pamphlet, you need to have some basic understanding of that. And throughout our course, we are going to learn how to ask for compressor and expansion device. But you don't need to worry about that because enough data is available. In fact, the manufacturer himself, he will guide you how to select compressor and expansion device. These are so simple. But the main intelligence that applies in design and understanding of condenser and evaporator. So each time you are going ahead to buy system, you need to first think of this complicated equipments which are connected. And the interesting fact is that both of the equipment which are connected here, they are actually the same. I mean, they are heat exchangers doing a different job. Here in the heat exchanger, condensation is happening, and here in the other heat exchanger, there is evaporation happening. So the name has been kept. according to the process, and they are not a different device at all. They are the same heat exchangers of different sizes performing different operations. So, in short, we are going to learn about three equipments: compressor, heat exchanger, and expansion device. See, so here you will have coils. Likewise, you have coils in evaporator side. Here you will have fan, and so the fan is here. Here you will find fins, and here you will find fins. So in short, these two are the same, but of different sizes. Okay. So our whole study will now be restricted to understanding heat exchanger, compressor, and capillary tube. Here it is expansion tube. In the next drawing, what we can see is the capillary tube is now being replaced by an expansion valve. So when we need to place capillary tube and when we need to think of expansion valve, it's a matter of caution. So expansion valve is used for a system where you can think of fluctuating the demand. I mean, if there is low heat in the room, then you can fluctuate the supply over here, and with that, the load on the compressor is being lowered. And if the load on the compressor is lower, then it is not going to take enough current supply, and with that you are saving some electricity. In turn, you are saving some money. This is an intelligent way of doing it. However, this is fixed way. There is no fluctuation. You cannot bring about any change in your system, and so the current required will be same. It will be steady. And due to these differences, okay, expansion valve and capillary tube. But for small system, it doesn't matter. It doesn't make much money out of what you're making the modification. So expansion valve is suggested for system of high load rating. Okay. Now we are moving ahead to understand what is capillary tube. Now see, this capillary tube which is over here, it is basically a copper wire which is later spiral and then connected between evaporator and condenser. So from here, flow will come inside. It will pass through this copper wire, which is being spiraled and placed in between these two, and then it will flow into evaporator. If we are using expansion valve, then the setup, the construction will look like this. Okay, so we have this demo along with us where I can see a normal window AC. I think its capacity is around 2 ton, or 10 or 2 ton. I'm not so sure. I've never checked it. But the main illustration behind this photo is that now we can see the components, right? So here there is an evaporator. Here there is a compressor. From compressor, a red line goes into condenser. Then the outlet of the condenser, it goes into capillary tube, and from capillary tube it will pass inside this evaporator, and the output of the evaporator, which is this blue line, it will go into compressor. So this is how the circuit has been completed. Now what I will do in my next slide, I will try to open this area and this cover so that you can see the heat exchangers inside. Okay, in construction wise they would be same, however they would differ in dimension wise. So you can see handle here, there is handle here. Okay, so I'm lifting off this cover. So here in this side you can see evaporator, see the construction. Okay, now let's go to the next slide. In the next slide, I have taken off the cover which was at the back, and over here you can see the construction. Okay, the size is different, but the overall makeup, the manufacturing, the heat exchanger is the same. So So with this I conclude that we are going to work upon three devices, which is heat exchanger, compressor, and this capillary tube. See, there is one more example which I have taken. This was of portable AC. So in terms of construction wise, here is the evaporator. Here is the condenser. You can find compressor over here. Okay. So the high pressure will pass through this tube and it will go inside here, and then after condensation the tube will take the rest of the refrigerant inside this capillary tube. It will pass into here where evaporation will happen, and from your top it will go back again into compressor.